All right, let's go. So for this first question, you're trying to leave r by itself. Now, there's a rule for when you're multiplying and dividing when dealing with an inequality. If you're ever multiplying or dividing by a negative number to both sides of the equation, then you are going to be switching the sign, okay? So here, to get rid of 3 over 7, or negative 3 over 7, you have to multiply. Let me write in a different color here. You have to multiply by negative 7 over 3. The negative cancels the negative, the 7, the 3, multiply this side by negative 7 over 3. So that's going to give us, this is going to cancel. We're left with r by itself. You multiply both sides by a negative number, which changes the sign here. And then negative 21 times 7, it's 147. Negative divided by 3, because it's positive times a negative, that's going to make a negative. Then I'm going to divide here, and we are going to get 49. So r is greater than negative 49. Okay, so anything greater than negative 49 would be a solution to this problem. Here, this one. For this one, we'll solve it, and then we'll put it in set builder notation. So here we're solving for t. 60 and t are multiplying, so you're going to divide by 60, divide by 60. Okay, you're left with t is greater than negative, cut in half, you get 4, cut in half, you get 2. Cut in half, you get 30, cut in half, you get 15. So negative 2 over 15. As you saw, I didn't change the sign for this one. Why didn't I change the sign for this one? Because yes, there's a negative number, but it's not what I did to both sides. It's only when you multiply or divide it to both sides. Okay? So that's the solution. And I'm going to put it in set builder notation. I do what you guys like to call the squiggle, the set of t, line t is greater than negative 2 over 15. There we go. Okay, next. What's the opposite of being divided by negative 6? Multiply by negative 6. So you're multiplying by negative 6. Cancel. Multiply by negative 6. Should put a dot up here. And my solution is c is less than or equal to negative 42. Okay? Now this one over here is a two-step equation dealing with an inequality. So here we are going to add 13 to both sides. Add 13 to this side. Add 13 to this side. Now we have negative 11y is greater than 55. Then we are going to divide by negative 11. Divide by negative 11. Y is now less than negative 5. Why did I change the sign? Because I divided by a negative 11 on both sides. All right. Here's a larger equation. So let's do this one. So first thing we're going to do is simplify both sides. This side is already simplified as much as it can be. This is not. Distributing the 4, this is going to end up to be 12t minus 20 plus 7. The 4 multiplied with a 3 and the 4 multiplied with a 5. Now I can combine like terms, negative 20 plus 7, so it's going to be 12. So let me write the next color. So it's going to be 12t minus 13 is greater than or equal to 8t plus 3. Here's a multi-step equation. Let's take away 8t from both sides. Okay, if we take away 8t from this side and take away 8t from this side, we're going to be left with 4t minus 13 is greater than or equal to 3. Now I'm going to add I'm going to add 13 to both sides. That's the opposite of this. So that'll get rid of this. I add 13 to that. I'm left with 16 is greater than or equal to 4t. Then divide by 4 on both sides. T is greater than or equal to 4. Why didn't I change the sign? I divided. I didn't divide by a negative number. So this sign stayed continuous. So this was really just a multi-step equation because nothing happened to the inequality at all. So the solution set to this is t is greater than or equal to 4. So if you were going to graph that on the number line, okay, if you're going to graph that on a number line, it would be 4 would be right here. A circle would be filled in, and t is greater. So remember, this line is representing t. So t is greater than 4. So all the numbers greater than 4 are that way. Okay? Just like another one from before, let's say the t's cancel out and you're left with a result that says like 13 is less than or equal to 14. This is not true, which means there is no solution to this. The set is nothing. There's nothing in the set of solutions. Okay? If something like this happens and it's true, like 13 is less than or equal to 13, okay? This is true. That means that all possible numbers are correct for the set. So very similar to the other one that we did. Here we go. Let's do this one. So this is a compound inequality, meaning two things are happening. So when it's written like this, it's saying and. It's saying negative 2 is less than or equal to x minus 3 and x minus 3 is less than 4. So anywhere, I'm going to graph both of them so you can see what I mean. Anywhere the lines overlap is the solution set because it has to be, both of these have to be true. So we add 3 to both sides here. We're going to end up with 1. You're going to end up with 1 is greater than or equal to x. Here, you are going to add 3 to both sides, and now x is less than 7. Or am I sounding like that so you don't get confused? So let's graph them both on the same number line. We're going to graph them both on the same number line. So the blue one, I'll do in blue. Okay, so that's going to make 1. So I'll find 1, put it right here. 1, it's a filled in circle. And x is greater than 1, so it's going this way forever. Okay? This one, x is less than 7, so let's find the green line here. Actually, I'll write it in black because green won't look like that one. So we'll see 7, 1, 2, 3, 4, 5, 6, 7. 7's over here. So 7's right here. Open circle, okay? And then less than meaning this way, okay? Only places where both are interacting are possible solutions. So any number from 1 all the way to 7, but not including 7, are the possible solutions to this set, okay? I could choose any of these numbers and it'll work. If I choose 7, it won't work, okay? All right, so it has to meet both requirements to be a possible answer. So if I put 2 in this equation, it'll work out. If I put 3, if I put 4, if I put 5, if I put 6, the answer will work out up here. All right, so let's go to the next one. This is an or problem, okay? This or that. So any of the two are true, and it's going to be fully acceptable. So if this is true, it's acceptable, and if this is true, totally acceptable. Okay? So let's do this part first. Let's solve this. Subtract 7 on both sides. Subtract 7 on both sides. So now you're left with negative 2m is less than or equal to 6. Then you are going to divide by negative 2, divide by negative 2. M is now greater than or equal to negative 3. Okay, the sign moved because I divided by -2 on both sides. Let's solve this one now. Let's do it in purple. So we're going to subtract 12 on this side, subtract 12 on this side. 5m is greater than 25. Then we are going to divide by 5, divide by 5. M is greater than 5. So now these are the two possible situations. And if any of these are true, then the answer is true. So let's look at these two sets. I'm going to do the graph in green because none of them are in green. Wait, that one's in green. We'll do it in purple. So here's the graph. -3 is more over here, so I'll start with that one. -3, filled in circle. M is greater than, so it's going to go that way forever, right? And then black, for the other one, that's 5. -2, -1, 0, 1, 2, 3, 4, 5. That's over here. This is an open circle. M is also greater than 5, so it can be anything in that direction as well. So in reality, the solution set is -3 that way, because it includes the 5. No, it does, Mr. Gassers. Not for this one, but 5 is included in this one, so it's totally acceptable because it can be either or of the two solutions. Okay? So this is any number above that. So I don't even need this because this one runs over the 5 one. And that's it. Done.